It's a note 2016 question. This is about two-dimensional motion and having multiple accelerations. Let us see what's the problem. It's a uniform circular disk of radius 50 centimeters. So let's write down the data given for you. R equal to 50 centimeters, that is 0.5 meter, is at rest. That means its initial angular velocity equal to 0. Why I said angular velocity is, we said it is free to rotate, turn about a perpendicular axis through its center. That means it's in rotational motion. It is subjected to a torque which produces a constant angular acceleration of. He has given an angular acceleration alpha as 2 radian per second square. What is the net acceleration is? First of all, we shall understand what do you mean by net acceleration. See, towards the center there is always an acceleration called a radial. Along the tangent there is another acceleration for a non-uniform circular motion called a tangential. A radial is v square by r, but v is not given for you. V can be written like r omega whole square by r, that equal to r square omega square by r. It implies a radial equal to r omega square. And we also need to know that a tangential is equal to r alpha. Both are perpendicular to each other. So the resultant acceleration is root of a tangential square plus a radial square. That's what we are supposed to find out in the problem, right? So to find that out, we need to find out a tangential, that is equal to r alpha. That's very much visible. So we can find out here a tangential is r alpha. R is given for you 0.5 meter. Alpha is also given for you as 2. That is equal to 1. A tangential is 1 meter per second square. I need to find out a radial. A radial. To find out that a radial or say a centripetal, we need to use the formula r omega square. What is it after 2 seconds? So I have to find out a radial after 2 seconds, means we need after 2 seconds what is its angular velocity is. I can use the formula omega final equal to omega I plus alpha t. This is similar to v equal to u plus at in translatory motion. Omega final equal to omega. Omega initially is 0 because we said it is started from the state of rest. Alpha I have given, it was given as 2. After a time t is also 2. So omega equal to 4 radian per second. Once you know omega, we can calculate a radial as r omega square. Radius is 0.5. Omega square is 4 square. 0.5 into 16, that is 8. A radial is 8 meter per second square. Now I know both a radial as well as the a tangential. Now I can calculate a resultant. Acceleration resultant is equal to root of a tangential square. I know that a tangential is already 1 square plus a radial square is 8 square, that is root 65. It is close to 8 because little more than 8, but we don't, he also asked approximately. We don't have any answer more than 8. So 8 is the answer that we can choose. So while we are solving the problem, the most important thing that we need to know is in a uniform circular motion, there is only a centripetal acceleration. But in a non-uniform circular motion, there is a tangential acceleration as well as the centripetal acceleration. The resultant of both of them acts in between them, right? So we need to find out radial acceleration. We also need to find tangential acceleration. As they are perpendicular, I need to use parallelogram law. By substituting the data, I can get the answer, that whatever may be the calculation is. That's how we have to solve the problem. Thank you for watching.